So this article is related to human activity recognition using the wearable sensors in MATLAB. So human activity recognition is basically HAR, which is basically a very important task in the various application, and it provides us the healthcare surveillance and the human computer interaction, and the dataset of 6 axis IMU sensor data is collected from the multiple subjects and performing the 5 different activities, including walking, jogging, sitting, standing, and laying. Okay, so these are complete algorithm need to perform through the uh, wearable sensors and highlighting the various techniques algorithm used in the field. So two popular machine learning algorithm I have used in it, and which is basically sport vector machine SVM and the random forest RF are employed, and their performance is evaluated accordingly. Okay, so results are basically approach that achieves an average accuracy of 95% and 92% for the SVM and the RF respectively. Okay, so the MATLAB implementation allows the easy replication and extension of the results, which propose the approach as potential applications in healthcare and sports accordingly. So here is the introduction, which provides us the complete machine learning algorithm in HAR by enabling the system. And this one is a comparison of SVM. Yes, this one is a comparison of SVM and the RF confusion matrix as well. Okay, this one is the RF confusion matrix, and this technique is SVM confusion matrix. Okay, this is more stabilized technique, and predicted class is more stabilized, and this one is not more stabilized than the SVM. Okay, so basically in this study I have just implications for various applications in terms of healthcare, monitoring, sports analytics, and the surveillance system as well. Okay, so background and motivation is that we have just added the variable inertial sensors such as accelerometer, gyroscope, and have become increasingly popular for the HAR due to their ubiquity, 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 low cost, and ease of use as well. Okay, so the growing demand of HAR system has led to increased interest in developing of accurate and efficient activity recognition as well. Okay, so the feature extraction and the classification, which is basically one of the most important technique which provide us. We have used the different standard deviation and different pre-processed data techniques, including mean, standard deviation, median, interquartile range, root mean square, and skewness, kurtosis, entropy, peak frequency, sum of frequencies below the 3 Hz, and sum of frequencies between 3 Hz and 15 Hz. So the feature extracted from the accelerometer and gyroscope data separately. So the study uses SVM and RF algorithm to classify the activities as well. Okay. So here is the data pre-processing and feature extraction, which is basically provided as Yang, one of the scientists who proposed the study on physical activity recognition using the smartphone sensors, highlighting the potential of smartphone sensors of activity recognition. Okay. So here is the classification and evaluation of SVM RF algorithm activities, and which are implemented using a radial basis function kernel, and while the RF algorithm is implemented using the 100 trees. So this is the problem statement. Problem statement is same like how the deposit growing interest in HAR, there are several challenges need to be addressed, including the development of accurate and efficient activity recognition technique. And the problem of HAR is basically complex due to variability of human behavior, sensor noise, and environmental factors as well. So that's why we have used our main aim is that to address this problem by developing a machine learning approach to recognize the human activities using the wearable inertial sensors. So this proposed approach has a potential to improve the accuracy and efficiency of HAR system. So here is the mathematical approach for the complete HAR system, including the SVM and the feature extraction techniques, including the RF system as well. Okay, so yes, these are the equations. Then methodology. Methodology provides us the complete parameters, models parameters, well-being and inertial sensing for healthcare as well, and the frequency including the 50 hertz. And thus in the data set we have used 5 males and 5 females and aged between 20 to 40 years, and 5 activities for 10 minutes, and resulting a total 50 minutes of data per subjects as well. So okay, so design and MATLAB simulation analysis, which is basically provide us the pre-processed data, is then segmented into window of size 2.56 seconds, and then SVM machine and machine learning technique and the RF algorithms. Yes, RF algorithm basically used to identify the feature extraction method for the classification of dynamic activities from accelerometer data, highlighting the importance of feature selection as well. Here is a raw IMU window, basically provide us the raw data set accordingly, and the next one is basically provide us the FFT spectrum feature extraction. FFT mean fast Fourier transform, and next one is basically box plot of 12 HAR features basically, which provide us the output of 12 HAR features, and next one is basically PCA of HAR features. Yes, this figure contains a PCA of 4 features, and next one is this provide us a SVM confusion matrix output graph, and this one provide us random forest confusion matrix accordingly. Okay, so here is the results and discussion accordingly, and the conclusion versus references. Let me just show you the output results accordingly in terms of MATLAB simulations. Done it. These are the MATLAB code, complete MATLAB code according to the walking, um, sitting, standing, lying, laying basically. Okay, so the all the parameter jogging, all the parameters are added in it. So see, these are the output results of raw IMU window, FFT spectrum AX channel, and the box plot for 12 HAR system. And next one is basically SVM confusion matrix. This one is basically PC of HAR features, SVM confusion matrix, and the RF random forecast confusion matrix as well. Okay, so I think it is okay now. So if you need to ask anything, you just ask me. I will answer your questions. Thank you.